Okay, well, let's see what we have today wrapped in a towel. Let's see if I can get the strings off of it without having to cut them. Oh, it's going to be tight. Got it. Marantz SR8000. Quartz synthesized. Looks like from the early 80s, probably 82, 83, somewhere in there, maybe a little sooner, we'll have to see. Well, I've got to say, it is a very nice looking receiver. I haven't powered it up yet, but I noticed this note taped to the top of the power transformer that says wire leads to burnt resistor. And they lead back over into here, down into here, but I also see something you know I despise. There it is. STK00802. And then there's the other one over here. And then even look, there's something on a heatsink right here that looks like another STK power pack. So I think I need to pull up a schematic on this before I even plug it in and maybe find out where those leads actually go. Other than that, it looks pretty nice. There's the tuner over here. Digital synthesized tuner. Take a look at the front board up here. Everything looks pretty good. Nice big Matsushita microprocessor. A couple of big power caps over there. But let's find out where those leads actually go down in here. I can't really tell from here. I'll have to trace it out and find out where they go. So it might be hard to show down here, but I see a burnt resistor that does have leads tacked to it. The designation is RN21. The leads aren't actually attached to the burnt resistor, they're just wrapped around one of the legs of it. So let's pull up the schematic and see if we can figure out what this burnt resistor is in the circuit and what it does. Okay, so I show Q701 and Q702 as the audio power outputs, STK0080 Mark II, which is what's in the unit. And then the IC that I cannot see, the driver IC, QN13 down there at the bottom of the page, is an STK3082. This is a schematic of the power output stage with the STK0080 Mark IIs, Q701 and Q702. So if I follow the burnt resistor right here, RN21, so it goes over to this pin right here, which goes to the 0.33 ohm output emitter resistor. So I've got to imagine that pin 8 and pin 3 are the outputs. So do we have a shorted output that's putting too much voltage out and damaging this transistor right here? I think we need to look at this IC. Let me go get a pinout for this IC and we'll see exactly what pin 8 does. I'm sure it's one of the two outputs. And then I'm going to have to just pull this whole board out because it goes into the base of this transistor right here, and if this burned up, there's a 4.7K resistor right here through a couple of diodes, and then they're shorted, but they want a 0.7 volt offset end to end. So I'm thinking it very possibly could have damaged this transistor right here, possibly damaged this driver IC as well. Looks like they're only maybe controlling the bias. So we'll have to see what pin 7 is. And then we'll have to look and see what pin 4 is. Plus 1.7, minus 1.7. So this might be just an external bias supply for this hybrid power pack STK0080. Okay, well here is the schematic on the STK004002, 502, 602, 702, and 802, all series 2. So here's pin 8. That's the pin that's connected to that 330 ohm resistor. And it is one of the 2 audio output transistors. So I think the next step is going to be removing the bottom cover from this unit, and we'll do just a simple ohm check between pin 8 and pin 9, and of course pin 2 and pin 3 check TR8, the other complementary transistor, and make sure that it's okay as well. So let's go ahead and pop the bottom cover off and see what we get. Alright, so here is the bottom of the STK0080 Mark II. So as you can see, this is labeled pin 10. So I'm interested in pin 9 and pin 8. I have my meter on the diode range right here. Short my leads, I get 0, that's good. That is not good. So let's check pin 2 and pin 3. And it is shorted as well. So let's move to the other STK power pack, and we'll go ahead and check pins 9 and 8. And I see a diode junction, that's good. Pins 2 and pin 3. And I see another diode junction, that's great. So that means that this power pack is good, and the other power pack up here is bad. But I still need to check the driver transistor to see if it's okay. And they didn't make this easy to get to. I don't think I can get my Hacko down in here and unsolder these leads because it's under this plate. So I may end up having to pull the whole board, heatsink, and everything out just to check that driver transistor, unless I can find it on the back. I do have a view of the circuit board so that I can blow it up and actually measure the components on the back of the board. Okay, so I can get access to one of the 2 transistors that you can see right here. I can get access to the other one, but I don't think you can see that one on the camera. I believe this heatsink might be in the way. So I'm going to go ahead and check from base to collector. I get 608, that's good. From base to emitter 133, that's bad unless there's a resistor across that transistor. So we'll check the other side. Oh, and it checks shorted all the way around. Let's just go to ohms. 1.2 ohms. And 27, 28 ohms. Not good. Let's just go ahead and check collector emitter on this guy. No, it does not check shorted. Interesting. Anyhow, I'm just in the diagnosis stage right now. I need to figure out what I think it's going to take to get this unit running and contact the customer. So at this point, I'm going to estimate, I think, for 2 power pack ICs, just to make sure, because if I change one, I really want to change the other one. If one failed today, the other one may fail down the road, and it's always been my policy that if one's bad and there's 2 or more of the same parts in the unit, I'm going to go ahead and change them both just to be safe. Plus, I think I want to change that driver IC because you never know what's going on with it. And of course, I'm going to have to change those 2 driver transistors as well. So I'm going to look up some prices and give this customer an estimate for these parts. If everything goes well, you may see a part 2 to this repair. If you enjoyed this diagnosis video, please consider subscribing to my channel and liking this video. It really helps my channel grow. Hopefully there'll be a part 2 to this. Remember, with your help, we can keep these things out of the landfill, out of the recycle bin, and out of the e-waste facility. Everybody have a great day. Thanks for watching. Bye-bye.